Friends, now let's talk about the fragmentation part. This one is important. So again, this is a 4 byte, 16 bit identification bit. This is 1 bit, 1 bit, 1 bit, and 13 bits. Let's start with this identification bit. So what is this fragmentation? It basically divides the packet. So why do we need to divide at first place? So let's say that this is router R1, this is R2, this is R3, and this is your destination. And this is your source. So your packet size is, let's say, 2100 byte totals including the header. And R3 says, buddy, I won't allow more than 500 bytes of IP packet. This is my limitation, or you can say my wish. I don't want. So what will happen in that case? If you restrict the size of the packet, that you can do by changing the MTU, maximum transmission unit, IP MTU. So what will happen in that case? How will you deliver this 2100 bytes of packet over to destination? So the answer will be like you will do fragmentation, right? You will divide the packet. So when you're dividing, let's say 2100 byte of data is divided in, let's say, 7 parts. You need to identify each of these parts, fragmented piece, right? So each of these will be given a number, so that once these reach at the destination, we can reunite these, whatever fragments we have, 5, 6, 7, right? So these need to be connected again. So it will only happen once you have identification value set. This is a 16-bit value which will be present. This is the purpose of this identification bit. Then what is the use of this reserved bit? So this one is always set to 0. It is not being used right now. Let's talk about this DF bit and MF bit. DF means do not fragment. If your bit of DF is set to 1, it means you don't want your packet to be fragmented. So what will happen in that case? Once the packet reaches at R3, like this one is source, R1, R2, R3, and this one is D, destination. So if this has a MTU value 500 limit, and you have this DF value set to 1, then your packet will be dropped because it doesn't allow more than 500 bytes. Alright, so ideally it's set to 0. So what is MF? More fragment. It tells you how many fragmented pieces are there after you. Let's say that our packet size is 2100 bytes, which means 20 byte header plus 2080 byte of payload. And if 500 byte is the MTU set by R3 MTU, that means it wants to allow 20 byte of header plus 480 byte of data. Each fragmented piece will have a header because it has to travel, right? If you are converting 5 kg bag into 5 pieces of 1 kg each envelope will have the address, will have the same detail. So every fragmented piece will have a header. 20 byte of header and 480 byte of data is allowed. I'm going to more detail. So how many packets would we need to deal with this situation? 2100 bytes of one IPv4 packet and 500 limitation. Now let's find out. If you divide 2080 with 480, the value will be 4.33 something. let's take it 5 is the ceiling value, so 5 pieces will be there. So the first fragment will be of 20 plus 480 byte. Second will be of 20 plus 480 byte. Means we can make 5 packets out of this 2100. I told you first and second. Third will be 20 plus 480 byte. Fourth will be 20 plus 480 bytes. 20 header plus this one is payload. Now what will be fifth one? If you add these 480 plus 480 plus 480 plus 480, so 1920 of data. But how much data we had? 20 byte of header plus 2080. You can reduce 1920 to find out how much data will be there in this fifth fragment. 20 byte plus 160. 20 plus 160. So fifth fragmented packet will have 160 byte of payload. So this MF bit actually tells you how many more fragmented packets are there after you. So if you go to the first fragmented packet, just check how many more fragmented packets will come after you. There are 4. So the value of MF bit will be 1. It means there are fragmented packets after you. Okay. And if you go to second fragmented packet, the MF value will again be 1 because there are 3 modes to come. This value will be 1. MF value equal to 1. MF value equal to 1. And similarly, for the third, there are 2 more to come. MF value 1. Similarly, after fourth fragmented packet, there is 1 more. This one will be 1. So at the fifth fragment packet, there is no MF value will be 0 here. So it tells you how many more fragments are there after your fragment. This is the meaning of this MF. Okay. Now let's talk about this fragment offset value, 13-bit value. What does it do? It basically tells you what is the position of your fragment. Our IPv4 size was 2100 maximum. That means 20 plus 2080. First fragment packet size was 20 plus 480. Second was 20 plus 480. Third fragment 20 plus 480. Fourth 20 plus 480 bytes. Fifth was 20 plus 160. Right. So it tells you what is the position of your fragment and how many bytes have already reached at the destination. So if you go to this first fragmented packet, just check, are there any fragments before you? This is the only first one. So fragment offset value will be 0. Means there is 0 byte of data before you that actually made it to the destination. And once you go to second position, that is second fragmented packet, how much payload already made to the destination? 480. So at second packet, the offset value will be 480 divided by 8. 8 is actually a formula. So whatever payload has been transferred, divide that by 8, answer will be 60. So 60 will be stored in this position, in this field for this fragment. And when you go to fragment number 3, how much data was transferred before this 480 plus 480? That is 960 divided by 8. Answer will be 120. So in this case, third fragmented packet, the value will be 120. Similarly, for the fourth fragment, the value of fragment offset will be 180. Okay. and for fifth the value will be how much? 240. So if you want to find out how much data has actually been transferred in total before this fragment, this packet number 5, you simply see this value and multiply it by 8. It will be 1920 bytes before this. And if you want to find a total now, total size of the IP packet by using this fragment offset value, you add this data into this one. So 160 plus 1920 will be 2080, and add 20 into that. Let me write again. So you add 160 plus 1920. Answer becomes 2080. This one is the payload of the IP packet. And if you want to find the total size, add 20 into that. 2100. This is that IP packet. It's very complex. Just for understanding purposes, I am doing all this effort. Again, this is a part of fragmentation. I explained you have to keep this df value as 0 automatically. You don't have to worry at all. You are not appearing for any competitive exam, so keep this df value 0. If you keep df value as 1, then fragmentation will not happen. Okay, and this bit is reserved for future use. This is the kind of number given to each fragment so that these can be identified at the destination and these can be regrouped. And MF value means more fragment, so it tells you how many fragments are there after you. Like in our case, there were 5 fragments. So when I go to this fragment, then there are 2 more fragments are there. So MF value at this packet will be 1. And this fragment offset tells you what is the position of your fragment. Where are you right now? Is it in the middle? Is it in the first place or on the last place? If you are in the first place, the value here will be 0. This is a way to find out where are you right now. If you are at this place, the value will be the size of the payload at packet number 1 divided by 8. Like it was 480 divided by 8, answer was 60. So very deep. You don't need to do any of these things in your career. Believe me, I'm just explaining you because you want to pass the exam, right? So this IP header is now clear. It was very simple to understand, but if you go in detail, it will become super complex. So just remember these names only, that's it. Nothing to worry much about. Like the size. Yeah, size is important, 20 to 60 byte. So thank you so much for your time. Have a nice day.